So I have this chart, and this chart covers a couple different areas of programming that I'm interested in, and I'm trying to figure out exactly what tools belong in each spot. Embedded's really straightforward. It's the reason I picked up Zig. I'm kind of using Zig as general purpose programming as well, which, I don't know, maybe that's not so bad. I also have TinyGo for embedded. I've done some stuff in TinyGo in the past. I like it. It's fine. I'm not sure when I would choose one over the other at this point, but I like having both those tools in my tool belt. For web, I tend to gravitate towards SvelteKit, TypeScript, CSS, HTML, kind of hard to avoid those. And then sometimes React if necessary. I have a lot of experience with React, so it's something I'm comfortable with. I don't particularly like it. I like Svelte a lot more, but that's one of them. For mobile, it's just Flutter for me. I've done native Android, I've done native iOS a long time ago. I've actually never written a single line of Swift, which is maybe something I should change. But yeah, Flutter is fantastic. I would build more Flutter apps if I didn't hate the mobile deployment process as much as I do, and the legalese behind the App Store and all that fun stuff. General purpose is the part that I want to talk about today, though. I've got Go and TypeScript. Go is fine, but I want something scripty, something I can just script together, something a little higher. And TypeScript seems like it fits that niche, but it's, I don't know, maybe I'm bored with TypeScript after writing it for 12 years now, somewhere around there. So I have this new idea, and this new idea is OCaml. So I've been looking at OCaml for a bit, and I follow a couple people on Twitter who tweet about OCaml a lot, and it's got me interested in it. So I want to talk about OCaml today. So what is OCaml? So if you're unfamiliar, OCaml is... here's the tour of OCaml. OCaml is an industrial strength functional programming language with an emphasis on expressiveness and safety. Okay, sounds cool. From a high level, the things that I care about, type safety, high level and functional is nice. Being able to build a single executable across multiple platforms is really nice. So I can build an executable for Windows, an executable for Linux, an executable for Mac. Where this starts to get a little weird is... OCaml standard library is really light. In Jane Street, Jane Street, the one that is maybe known for major market manipulation at the time of this video, has a really great library called called Base. So Base is a standard library for OCaml that builds on top of the existing standard library and provides some new things. That also works on all platforms. Jane Street also has a library called Core. Core is built on top of Base. Core does not work on Windows. That's my understanding. I could be wrong on that. I'd love to be corrected if I am wrong on that. I'm still new to the OCaml scene, so there's a good chance that I may not have the most correct information. Anyways, that kind of complicates things for me because I want something general purpose that can be used across all platforms. Regardless, I thought I would try it and play around with it. So I'm just going to give you a really quick intro on a couple things here, and then we're going to talk about some code that I've written in OCaml, because as I like to do when I learn new things, I take an existing project and rewrite them in another language, and I actually really like the OCaml implementation. So while we're here, I just want to point out a couple things. This learn is what I went through. I clicked on Get Started and walked through the Get Started piece. There's some interesting guides and an OCaml cookbook as well, which is neat. I probably need to read through the cookbook because there's actually something that I did not like about the OCaml implementation that might be covered in the cookbook. So just some stuff to look at, go through this. If you have functional programming experience, like I've got F# experience and a fair amount of Clojure experience, I just jumped to the intermediate section and then quickly found myself going back to the beginner section just to get an idea of how OCaml fits together. So specifically, the tour was really useful for me, and then looking through the language documentation, and then looking at some of this stuff like bootstrapping a project, managing dependencies, and all that fun stuff. Okay, so with that in mind, that's not the right tab. Let me close this. This is the right one, and it's nice and hopefully legible. Okay, so this is ADL. So we've talked about this project so much on the channel. I will probably keep this in Zig. It seemed the Zig version is we'll just consider that the source of truth at this point. But I did port the Zig version over to OCaml to try it out. So there's a couple different things going on. So the very first thing is where we have a build.zig in Zig, what we have in OCaml is called Dune. Sorry about that. So Dune is essentially a build tool for OCaml. This actually reminds me very, very much of line again from Clojure. So it's also a build tool. Clojure line again. Some information here. This is tiny. This is the Clojure build tool. It's nice. It was really helpful when learning Clojure. There's also another one called Boot in Clojure. So the point being, it's a build tool. So you can use Dune to build your project, manage dependencies, all of that fun stuff. There's also OPAM, which is the OCaml. I actually don't know what the PAM stands for. OCaml package and modules, maybe? OPAM. Let's find out. OCaml package manager. That totally makes sense. That makes way more sense than anything I just said. So OCaml package manager also lets you install different versions of OCaml and manage those and switch between them. It's kind of like your virtual environment in Python. So that's something that I used as well. Let's take a look at the ADL itself. So there's two parts. There's a main, which is, sorry, here's the OPAM file. I mentioned this is kind of like the virtual environment. So there's information about the OPAM that's used for this project. The Dune project, which we just had up. The binary itself is right here. So there's a main ML file. So you can see that this is essentially just getting those args from the system args and then passing them to ADL lib run. So ADL lib is the main meat and potatoes of this. So this is what we'll be spending most of the time talking about. Okay. So let's just talk through this. So there is that run method, right? ADL run. So if we look down here, so here's that entry point. So this is defining a function. So let defines something, defines a variable. In this case, it defines a function. So if we didn't have args here, it would be a variable. Since we do have args here, it is a function, or any argument, I should say, not specifically args, because that's the name of this variable. Okay, so we're defining run here, and it takes in args. So we get a command, we parse the command, args, and then this let in combo is kind of interesting. So this is locally scoping a variable for the things that follow it. So in our case, this command variable is only valid for the scope. So then we pass that command after we parse it into execute command. Really straightforward. So what do I like about this? This is really, really nice. This parse command is beautiful. So this match with seems to be a pretty common practice with OCaml. I would argue that it's probably the bread and butter of like your logical matching in OCaml. So there's a couple different things here. We're matching args, and if we have an empty list of args, we run help. If it is specifically create, then we do a little bit here. If it's create with an empty list, then we say that there's no name supplied for the ADR, and then an example of how it should be used, and then return unsupported. Regen runs regen, regardless of if you pass anything else after it. And then if you don't have any of these matches and you need to fall through to the default case, that is help. Really, really nice. So this is essentially parsing those commands for you and converting them into something useful. So where are those defined? So those are defined up here. So we have a couple different options. For command, we either have create with a string, we have regen, we have help, and then we have unsupported. Okay, so let's go back down here to the execute commands. Now that we've parsed our command, we pass that into execute. So execute, again, is doing some matching here. So we have, this is defined as a function, and it is matching on the command that gets passed into it. So if it is create, then we take the name, which is this string up here. So we take that name, and then we execute this block. So this block ensures that the directories exist. It gets all the files in the ADR directory by using this get ADR files. We can look at that in a second. Binds that to files, and then figures out the number of files by looking at the length of that list, and then calls generate ADR with number and name. And then finally, we rebuild the README. Regen's very similar, ensures the directories, rebuilds the README. Help uses print string to print the embedded templates for help content. Unsupported also prints the embedded templates for help content. This is the part that I didn't like. So I feel like there's probably a better way to do this. I realize that there's Jane Street has a library for embedding files. The way that I ended up figuring out how to solve this feels really clunky, and I need to remember where that's at. Oh yeah, so in this templates folder, I have a Dune project here, and I'm using an action to essentially take all these and as a part of the build process, embed them into the embedded files piece that I just mentioned moments ago. So you can see that we let readme template, and then it's equal to a multi-line string that is essentially, hey, just cat the readme template, paste it in there, and then echo the closing of that multi-line string. Feels really clunky. It works. It works great. It just feels a little gross. And then, yeah, you can see here how that is wired up. So you can see the embedded templates there. We copy that in and make it available. Okay, so really the thing that we need to talk about is the get ADR files and then generate ADR. So we talked about parse. I'm going to collapse this. And we talked about execute. I'm going to collapse that as well. And we talked about run. So rebuild readme, again, that's a function. We get the template content here by matching on read file if exists with the string. So this is going to call this read file with exist and then match on the output. So if there is some content, then we return the content. If there's not content, we return the readme template. This is so clean. I love this. And then to add to that, to make this even farther, I say return here. This isn't returning. This is binding that to the template content and making that available after this end statement. So where do we use that, right? So we use that further down here. So we have let files get ADR files. Again, we need to talk through that in just a moment. We do some string concatenation here. There's a string list map fun file. So this is essentially, we are mapping with an anonymous function that takes a file and uses sprintf to do some formatting of that string to convert it into a markdown friendly list item with a link. Files passed in both these times, one for this S and one for this S. There might be a cleaner way to do that. Finally, if we look at the closing parens here, you see that we have to pass files in here, and then we bind that to contents. Same thing here. So we have a timestamp. We call get timestamp to get the timestamp. And then we have our final content. We call the substitute template function. And what this does is it takes the template contents and then runs some substitution. So we substitute the word timestamp with the timestamp, and we substitute contents with the contents. Finally, we open an output file. This is going to be the README. We bind that to OC, and then we use this output string function right here, which writes the string to a given output channel to our output file, and then there's the content, and then we close it because we should close our files after we're finished with them. Finally, we print that the README has been regenerated. This is pretty clean. Actually, one thing I really wish, and maybe I should have done something more about this, is I feel like my syntax highlighting for OCaml is not very good, and I feel like if I had more contrasting colors from a visual perspective, this might not feel as cluttered. But after reading through this a couple times and writing it out, it feels clean. I really like this. Okay, so generate ADR. This one's fun. So this one takes in a number and a name. So we have to pad the number, right? So we call this pad number function. Pad numbers up here. We just use sprintf, and here's our formatting, and then we pass in the number. This is a function definition. It's all on one line. It's really concise. It's really clean. It's out of the way. It's not saying, hey, I demand a bunch of space because I'm this big complicated thing. In fact, it's the opposite. It's saying I demand very little space because I'm just doing one thing. Really nice for readability. So we get our padded number. We get our heading using sprintf again. We sanitize the file name here using the sanitize file name method right here. Again, a really small function that's using a regex replace. So it's using a Perl style regex. We're compiling that here. And then this is a named argument. So in our case, this is kind of interesting. So with OCaml, if you do the tilde for a named argument, you can place it in any order. So this is the same as this. Oh, I hope I didn't lie to you. Okay, maybe I did lie to you. Oh, I see. Sorry. I put that in the wrong spot. So that would go here. And that totally works too. So with the named arguments, you can place them in any order, which is kind of neat. So that is sanitized file name. So if we go back here, now that we have the safe name, you can see that we create the file name using sprintf to create right there. We use the padded num and the safe name. We bind that to file name. And then we look for those template contents. So similar to the README contents, we check to see if that file exists. If it does, we return those contents. Sorry, we bind those contents to template content. Otherwise, we use one of the embedded values. Call substitute template to substitute the name with the actual heading, and then we write everything out and print. So there's substitute template, again, regex and some replacements. Folding on the list, kind of nice. Timestamp using Unix local time, and then using print sprintf. There's probably a cleaner way to do this. I'm sure some OCaml expert could one-line this, but this is what I found that worked well for me. Pad let replace file name, read file if exists. So here's that piece. We use try to essentially try that, and if we succeed, we load the content, and then return that with some. So some, you don't have errors, you have some and none. So you have option types that you're essentially working with OCaml. And that's what we're returning here. So if there is some, we return an option of that content. If there's not, then we return none. We've almost covered everything. So the last two files are ensuring that directories exist. There's a list of directories. We use an iterator to iterate through that. And then for each directory, we try Unix makedir, making the directory with a Unix error. So if that error exists, then we are returning an empty. Actually, I'm glad I'm hovering over this. I was going to overlook this term, but what would be called a unit. So essentially a indication that something has happened, but it is not. There's no return type necessarily associated with it. We pass in all of the directories to list iter, and it applies that function to each directory one at a time. And then we do some checks here. So if this does not exist, then we open the file, and then we write the embedded template out, and then we close the file. Getting the ADR files is going to be kind of similar here. So I mentioned that we don't have errors. But we do have try and we have with here. So you can see that we're essentially trying to do something that can fail, right? And when we do that, what we're doing here is we're trying this thing. And if we do happen to fail with a sys error, then we are converting our return type to something that our function is expecting us to return. So in our case, if we have a sys error, we just return an empty list because we are not able to find any of those files. Otherwise, we can use sysreaddir here to read the directory, get all of those files in that directory, convert that to a list, and then filter on that list. So we want to filter out certain ones like README, assets, templates, anything else we might want to add in the future would go here as well. This is the not equals operator, in case that's not familiar. It wasn't for me. I expected it to be not equal. And this is also valid, but in a different way. So the syntax is valid, but the logic here is different. So there are two different types of equality. There's structural equality and non-structural equality. I don't remember what the other one's called, but they are essentially two different operators. And if you go through the Tor, you'll find them there and see which one you might want to use and in which case, and learn more about them. In fact, we'll pull that up in just a second because that seems useful. Finally, we're piping this in. I didn't even mention the pipe operator earlier. So we're piping this into list sort, and then we're calling string compare to help with the sorting. So we're providing a function, the string compare function, to the sort function, and then we're taking the output of this and piping it into this. Pipes are really nice. They're a great way to restructure things to focus on readability. And a lot of times what you're doing is you're taking input, you're transforming it, you're transforming that, you're transforming that, you're transforming that, and then you're piping it out. And pipes are really, really great at defining those transformations one step at a time. I grew to love those in Clojure and F#, and it's really great to see those in OCaml as well. Okay, let's talk about equality before I forget. Okay, so OCaml also has the double equal operator. So one thing that's important is with OCaml, you use the equal operator for assignment, but you also use it for testing equality. You can use the double equal operator to test the physical equality, less than, greater than, the fishtails, whatever you want to call them, is the negation of equals, while not equals is the negation of physical equality. So essentially the single equals here is testing the structural equality, where the double is testing the physical equality. And structural equality is essentially comparing the content or like values of two objects rather than their memory locations, where physical equality would be characterizing them based off their memory locations. I think I got that right. I think that's it. I just wanted to walk through this. I find this code really expressive, clean, and easy to read, and it's around the same amount of lines of code as the Zig implementation, which is always nice to see as well. And then, using Dune, I can build an executable for this and ship that as well. And it's a very portable executable, very similar to Go, actually, which is really, really nice. I think that covers it. I just wanted to walk you through OCaml and talk a little bit about it, mostly because I might end up writing more of it. And if I do, I'd like to share some of the things I find interesting on this channel. So thank you for taking the time and detouring with me from our regularly scheduled programming into something different. If you haven't yet, consider subscribing to the channel. Join our Discord server. We're all friends here and there, and it's becoming a really nice, fun community to be a part of. I'm maybe a little biased, but I have learned so much from so many people, and that's kind of what I'm here for. Besides that, if you found the video helpful, interesting, or you just want to see more of it, give it a thumbs up. That lets me know that that's what you want to see more of. I think that's it. So if you haven't yet, I would really appreciate it if you had a great day. Thanks.